let's explore a quintic function, which is a polynomial where the highest power of x is 5. Our specific function is g of x equals x to the fifth minus 5x cubed plus 4x. And here's its graph. You can immediately see it's more complex than a simple parabola or cubic. It swoops up and down, changing direction multiple times. This shape tells us the function has several interesting features we can analyze. First, let's look for its roots, the points where the function's value is 0. These are the points where the graph crosses the x-axis. Our function has 3 real roots here, one at -2, one at 0, and one at approximately 1.4. Next, we identify the critical points. These are the peaks and valleys of the graph, where the slope is 0. We have 4 of them, 2 local maximums and 2 local minimums. These are found by calculating the derivative of the function and solving for where it equals 0. Finally, an important note about quintic functions. While they can have up to 5 roots, not all of them can be found using nice, neat algebraic formulas like the quadratic formula. For many quintics, including this one, we rely on numerical methods to approximate the roots, just as we did here.